Good afternoon, dear colleagues, dear guests. I'm very happy to see you. Today is the 14th of April 2021, 2 p.m. Moscow time, and let me open a dissertation committee session dedicated to the defense of dissertation by Dmitrii, Vasil'evich, Matias, seeking a degree in solid mechanics on the topic application of spatial description and problems of hyperbolic thermoelasticity and the dynamics of deformable solid body. According to the Act of Academic Center of St. Petersburg University, Gnetov Alexander Volunteer, dated 2nd of February 2021, I, Elena Vladimirovna Kustova, Doctor of Physical and Mathematical Sciences, Professor of the Department of Aeromechanics of St. Petersburg University, was appointed committee chairman. And I would like to also introduce the other members of the station. Alexei, Professor Holm, Johannes Altenbach, Doctor of Engineering Sciences, Professor of the Departments of the University, Universität Magdeburg, Otto von Guericke University. Geo, can you hear us? Also, yeah. And Alexei Prokhorovich Kisilov, Doctor of Physical Mathematical Sciences, Professor of the Department of Higher Mathematics and Mathematical Physics, St. Petersburg. Can you hear and see us? Yes, I do. Vladimir Anatolyevich Polansky, Doctor of Engineering Sciences, Director of the Institute of Material Science, Russian Academy of Science. Can you hear us? Yes, I can. Alexei Viktorovich Porobov, Doctor of Physics and Mathematical Science, Chief Research Fellow of the Institute of Problem of Machine Engineering, Russian Academy of Sciences. Can you hear and see us? Yes, I can. Thank you. Viktor Anatolievich Yeremeyev, Doctor of Mathematical Sciences, Professor of Gdansk Polytechnic University, Poland. Can you hear soon? Yes. Also with us is the candidate, Dmitrii Vasil'evich Matias. Can you see and hear us? Yes, I can. And also the academic advisor of the applicant, Elena Ivanova. Alexandrovna Ivanova, Doctor of Physical Mathematical Sciences, Professor of the High School of Theoretical Mechanics, St. Petersburg Polytechnic University, named after Peter the Great. Can you see and hear us? Yes. To improve the quality of the communication, please, those members of the station committee who are participating with us online, please switch off your microphone when you don't have the floor. And I would like to remind you that audio and video recording is broadcast online live on the website of St. Petersburg University. It's accompanied by simultaneous interpretation from Russian to English and vice versa. Also, there's an email on the website, so we can say you can send emails. Any viewer can send emails, questions that directly relate to the presentation of the candidate and the topic of dissertation. All questions should be signed. Academic affiliation should be also mentioned. Anonymous questions are not going to be regarded. Neither will be regarded questions that have no relation to the dissertation. In accordance with the procedure of awarding academic degrees of Candidate of Sciences and Doctor of Sciences in St. Petersburg University, a dissertation committee session is legitimate when not less than 2/3 of the established dissertation committee membership, but not fewer than 4 people, are present. our dissertation committee consists of 6 people. All 6 people are present, including 5 members of the dissertation committee, in an online mode. We have the quorum, we have the connection with everyone. I would like to present the agenda now. We have 2 hours for the session. The first item is a short presentation of the chairperson about the paperwork that has been submitted by the candidate. 5 minutes. A short presentation of the candidate of not more than 15 minutes, covering the key issues of the dissertation. If we can, of course, would like to give 2 minutes if there's a delay, but not more than that. Then questions to the defendant, strictly on the presentation, not more than 2 minutes per question, and answers of the defendant, not more than 5 minutes for all questions. Then all members of the dissertation committee will take turn in presenting their reviews and asking questions and suggestions. 10 minutes per speaker. After all the members of the dissertation committee have spoken, then the chairperson of the dissertation committee will have 10 minutes to present her review, and then 20 minutes are given to the defendant to answer all the questions and critical remarks. Then open floor discussion is announced. Anyone present in the room will have the chance to ask questions, but not more than 2 minutes per speaker. And if you want to speak, you have to take this opportunity. You have to introduce yourself, and before that, you have to log your name into the register. If there are any questions that have arrived via email, then we'll read them. Then after that, the defendant or the candidate will have 2 minutes per question to answer them. Then the academic advisor of the station will have 3 minutes for a presentation. Then there will be a deliberation of 5 minutes before open call roll voting. And then after that, then we can switch off the broadcast if we need this interval for deliberation, and then open a voting procedure. Then decision will be taken to award or not to award the sought academic degree. And after that, the concluding statement will be given to the candidate on not more than 2 minutes. Have any questions as to the agenda? No questions. Thank you very much. Then I would like to ask everybody present, please switch off. Those who are in the room, switch off your telephones or the sound of thereof. Now I'd like to start. The dissertation of Dmitrii Vasil'evich Matias, seeking an academic degree of Candidate of Physical and Mathematical Sciences in the academic degree 01.02.04, Mechanic of Deformed Solid Body. On the topic application of spatial description and problems of hyperbolic thermal elasticity and dynamics of deformable solid body, was accepted for defense by the act of the Academic Secretary of St. Petersburg University, dated on the 15th of January 2021. Dmitrii Vasil'evich Matias wrote his dissertation in St. Petersburg Polytechnic University of Peter the Great, supervised by the Doctor of Physical and Mathematical Sciences, Professor of St. Petersburg Polytechnic University, Elena Alexandrievna. The number of publications is 4 in refereed, peer-reviewed journals approved by the Ministry of Science in Petersburg of Russian Federation, none in a Web of Science and Scopus for publications. All the paperwork that has been submitted are at the disposal of the Council, Dissertation Council, Dissertation Committee work, the curator of which is here. And do we need to call all the names of the documents that we received? No. No questions. No. Thank you very much. Now I'd like to give the floor to Dmitrii Vasil'evich. You have 15 minutes. Thank you very much for my work consists of 3 chapters. In the first chapter, hyperbolic thermoelasticity is studied. And then in the second and third chapters, the problems of dynamics of a deformable rigid body are considered. This wide range of tasks is traditionally considered using material descriptions. The spatial description widely used in fluid dynamics, but for the specified range of problems, the possibility of its use have been studied very little. The relevance of the first chapter is owing to the fact that active studies of hyperbolic thermal elasticity were carried out for a solid, but for a gas this issue is poorly studied. The relevance of the second chapter is due to the fact that for a more accurate description of the hydraulic fracturing process, it is not necessary the dynamic of a fluid can be considered only in a spatial description, and for a rigid body, the possibility of using a spatial description is poorly studied. The body with a crack and such a description has not been considered previously at all. The relevance of the third chapter is explained by the fact that no numerical studies have been carried out for a special Kostereth continuum recently proposed in the literature. Initially, the authors are indicated here proposed the idea of hyperbolic thermal conductivity and thermal elasticity, were engaged in the experimental determination of the relaxation time for the heat flux. Some of the authors are engaged in analytical research of hyperbolic waves in the fluid. The second block lists the authors in whose works the dynamics of a deformable rigid body is considered in a spatial description. The third block represents the authors who proposed to use and further develop the concept of a medium with rotational degrees of freedom. The purpose of the study is to apply a spatial description, firstly when comparing hyperbolic waves in a solid and in a gas that arise when considering hyperbolic thermal elasticity. Secondly, when considering the process of opening a crack in a rock. And thirdly, when describing the process of propagation of waves at the interface between media and in a continuum with rotational degrees of freedom. The first chapter is devoted to the study of hyperbolic thermal elasticity using spatial description for gas. This approach is a natural extension of the system describing its dynamics. At the beginning of the second half of the 20th century, a modification of the Fourier law was proposed, as a result of which the heat conduction equation acquired a hyperbolic form, and as a result, the final velocity of the heat flux propagation was taken into account. And an infinite layer of small width is considered. The laser effect is distributed deep into the layer according to the Bourguier's law. In time, it was the form of a delta function. The object of research are an elastic solid and an viscid gas with thermal conductivity. The equation of state for which is assumed to be analogous to an ideal gas. Relaxation times of both media vary around 0.1 and as for a gas, this problem is solved numerically for the first time. The work compares the behavior of waves in both media. Integral balance equations are formulated in a fixed volume, and a linear theory is considered for a rigid body. On the basis of an energy balance equation, I derive an equation describing thermal conductivity. The laser action is set by the source term on the right side. The slide shows the dimensionless system. For a solid, heat flux in this equation is not expressed in terms of temperature. The relationship between temperature and the heat flux is presented in a separate fourth equation. Thus, a system of first-order equations is written in an integral form, which is convenient for numerical computations. Using the finite volume method, the indicated system valid for small perturbations when the physical properties of the media are assumed to be constant. For a gas, the system of equations described hyperbolic thermoelasticity is formulated for the first time. Unlike rigid body system of equations are non-linear in terms of containing the product density and temperature. They are both variables, not parameters. Using the finite volume method, I obtained a solution in a solid for a layer with a width of a micrometer. For four variables, the dependence of the distribution of their values over the layer thickness was determined. They presented a graph show the temperature deviation from the initial one at 2 points in time. For the first time, a solution was obtained for the problem of hyperbolic thermoelectricity in a gas. Various boundary conditions are considered. When the temperature density are fixed at the boundary zone, negative temperature deviations near the boundary can arise in a gas, just as in a solid. In both cases, the waves do not collapse, but in a solid this does not happen due to the linearity of the system, and in a gas because of the binding between the thermal and acoustic processes. In the case of gas, the litigation is more pronounced. The amplitudes of waves in a gas are of the same order of magnitude. A linear formulation for gas is considered. It is determined that if the change in the physical properties of the gas with a change in temperature is not taken into account, then the difference between the formulations is significant, with the initial temperature deviations of several tens of degrees. In a solid, according to Novatsky, a linear theory that ignores the dependence of physical properties on temperature can be considered with a temperature deviation no less than 10 degrees. It was established in the work that at times comparable with the relaxation times, it is necessary to consider hyperbolic thermoelectricity and simplified theories such as an uncoupled adiabatic process, and hyperbolic thermal conductivity cannot be applied to describe the process of heat and mass transfer. Both wave velocities and amplitude differ. In this work, the influence of the relaxation time of the heat flux on the behavior of waves is investigated. With a decrease in the relaxation time, the order of the waves is changed. Energy is redistributed from a slow wave to a faster one. For both a solid and a gas, the assumption is refuted that a certain value of the relaxation time, two waves can degenerate into one. Unlike a solid, for a gas, it's possible to consider an unsteady flow with a speed close to the speed of waves. It is determined that the influence of the non-stationarity of the flow, the relative position of the waves, is limited by the zone near the boundary. Thus, for the first time, a numerical solution of the problem of hyperbolic thermoelectricity, elasticity in a gas, was obtained, and a comparative analysis with a solid was carried out. The time and space scales are established, on which the simplified theories cannot be applied. And it is necessary to consider hyperbolic thermoelectricity for gas. The case of unsteady flow is also considered, and the influence of the flow rate on the form of the obtained solution is determined. In the second chapter, the dynamic problem of crack opening in the plane deformed formulation is considered. A crack is defined by a vertical cut, which is acted upon by internal pressure. Well, one member of the dissertation committee is absent, so the first technical break is announced. because Professor Yurimev, he is back. Yes, we can. Yeah, please. Victor Anatolyevich, can you see and hear us? Yes, I can. Yes, you vanished from the screen. Yes. Yeah, there were two of me, and now there was only one. Thank you. So the technical break is over. Please continue. So, and the task also uses special decree. The description on the basis of the well-known equation, I obtained an integral form of the ratio of deformations of velocity for use in the finite volume method, for resulting in equations together with the balance relations form a system of integral equations in which the unknowns are density, velocity, and deformations. So the real problems of opening a crack in a rock, the width and length of the crack differ by several orders of magnitude. Therefore, speaking about the transition to a decreed formulation is logical from the point of view of the described process to use a highly elongated mesh. The computational program that implements this idea was written by me in Python. And then, as already mentioned, when using a spatial description, the displacements do not have a clear physical meaning, so the question arises how to determine the position of the crack walls. In the literature, it's proposed to integrate the velocity of surface points for boundary cracking. A new approach is proposed in my work. In the process of solving the distribution of the partial density is determined, on the basis of which it is proposed to determine the position of the crack. A solution to the dynamic setting is obtained. A pressure that increases linearly with time is applied to the fracture. The presented mesh is non-uniform for clarity. The area around the crack is shown. As a result, a phased crack opening can be seen. Based on the density distribution, the position of the crack wall is easily determined. In addition, a solution to the problem of crack opening was obtained in a quasi-static formulation which implies the elimination of the terms containing the velocity from the balance equation for the momentum. This makes it possible to simulate processes of any length in time. The dynamics of the process due only to external influences. The slide shows the density distribution on the left hand, the computation domain near the crack. In this work, the grid convergence was investigated, and the influence of the horizontal vertical grid density was considered. Also, the solution was compared with what obtained using the material description. The solution of the dynamic problem at a fixed time is considered. The results showed the qualitative and quantitative similarity of the stress distribution. The results of calculating the program developed in Python agree with the results obtained in the material description using the commercial package ANSYS. A separate problem was considered in which the external force decreases literally to a point of time of 1s, and then a separate problem, the relation between deformations, the relationship between deformations and the field of velocities is formulated as an integral form. And for the numerical part, solution of the crack opening from a spatial description of the finite volume method are used. The third chapter examines the Kosterett continuum and spatial description. A special type of Kosterett medium without translational degrees of freedom with a spherical tensor of inertia is considered. Two environments with different properties are considered in a two-dimensional setting. incident plane wave propagates from the left half of the square area to the right. The boundary of the media is located in the middle. And there are two constants, alpha constants with an index indicate the ratio of the velocities of different waves in two media, as well as the relative damping. To carry out numerical modeling by the finite volume method of the wave propagation process, the system of equations for each medium is written in integral form. In the dimensionless form, the system includes the constant described in the previous slide, and numerical studies carried out for different levels of external damping. And in media, depending on the ratio of the stiffness of the media, the angle of incidence, the wave amplitudes can have a different order of smallness, which means the appearance of 1 to 4 refracted and reflected waves. To find asymptotic estimates of the amplitudes of reflected and refracted waves, in which the conditions of ideal contact of the interface between the media are used, the numerical solutions are compared with the available asymptotic estimates. The study varies the relative stiffness of two media and the angle of incidence of the wave. The program for solving this system was implemented by me in the Python environment. The distribution of the amplitude of the rotation vector at a fixed moment of time shortly after the passage of the wave through the interface between the media is obtained numerically. It is asymptotic estimates are shown in the upper right-hand corner. The paper considers cases for which a different number of waves is obtained. It's impossible to determine the type of wave from the distribution of the amplitude and of the rotation vector. Therefore, to establish it, the analysis of wave projections is carried out. It was found that the solution also strongly depends on the angle of incidence. So for the same stiffness ratio, a different number of waves can arise. In the above results, an incident torsional wave was considered, also confirmed by numerical modeling that the available results are similar to those obtained when replacing the incident torsional wave with a flexural one and inverting the stiffness ratio. This slide shows the relevance of the first chapter. This slide shows the provisions for the defense for the second and the third chapter, and then the materials and the main provisions of the work were tested in the above conferences that you can see here. Thank you very much, dear council members, dear committee members. Thank you for your attention. Thank you very much for your presentation. Dear colleagues, do you have any questions to the candidate? While the colleagues are thinking, I will ask my questions as a chairperson. I have the first formal question. Would you have publications with co-authors? How did you divide the contribution? What did you do there, and what did the colleagues do? Yeah, now I do answer immediately, yes. And the publications here, with Ivanova, Elena, with Stepanov, Matvey. I wrote my program, and also I set the goals, the tasks. And with Svitokin, again, I also wrote my program and also analyzed the results, and I set the goals. In the work with Ivanova, I interpreted the results. Yes. Thank you very much. Did you register? Have you registered your program? It's not registered. In some of the works, it was developed as part of a grant. There are there are more simple calculations, but this program does more sophisticated calculations. Thank you very much. It would be great to have this program for public use. Thank you very much. Any questions from the members of the Dissertation Committee? Okay, I will ask a question. I have a question. In one section, you discuss numerical algorithm. You introduce viscosity, which is not a property of the material, but this is used to quash the oscillation. Can you comment whether it's feasible, and how can we interpret the coefficients that are not part of the physical model? Thank you very much for your questions. In my work, well, this was only for viscosity. This is only this was only had to do with the rigid body. So yes, it could be used in other variants of the body, but maybe in relation to the model of a body. This is part of a big discussion in the academic community, and you have to look at it very closely. The second question is, if I understand you correctly, your work focuses focus on Kosterad continuum. How do your results differ from the traditional results, from the classical medium? Also other media, and where deformations are studied, and can you say anything how this affects your results? I think that everything will be different. Well, this is a very special environment, and it's very difficult to find analogies in other media, and we can use these results in other industries, but the speed of waves there are no limits on the properties of the longitudinal and the longitudinal waves, and it's very hard to compare it with other media. Well, when there's translation in the Kosterad continuum, this is a good avenue for further research. Do you have any other questions from other members of the committee? Can we read our reviews? We can ask questions and then thus limit our comments when we read the review, or when we read the review we'll do all the commenting. We haven't heard. I have no questions. No, nothing. Thank you. Do you have any questions? Then I will ask my question. The most interest for me was chapter 1 because I am interested in gas dynamics. I look at the where do you molecular viscosity, why do you overlook it? Thank you very much. Maybe this can have a broad answer, but when I look at gas, yes, I admitted that property, but and I didn't focus on this. When I read your review, and I saw that there are some works that where viscosity was considered. If we introduce viscosity into the model of the gas, this goes to quasi-static wave solutions. The more viscosity there is the acoustic effect is fading. That's very interesting. Different results are obtained here. When we took constants for air, then we can use other constants for everything. But when the higher the viscosity, then the more thermal conductivity. The highest for thermal conductivity. And if we have any questions, then we can proceed to the next point. Then the reviews will be read out by the Dissertation Council members. Dmitrii will answer all the questions in a bulk after all the reviews. 20 minutes to answer all the questions will be allocated to Dmitrii. No external reviews have been submitted for the dissertation, and therefore members of the dissertation committee, all the reviews have been published on the website. You can have access to them. You don't need to, if you don't wish to, don't need to read the whole review. Maybe you'll focus on the key issues, but comments should be read out in full. And critical remarks. Professor Altenbach, I have two questions, and I already asked these questions. One, it's very hard to find studies in this and to compare the results with other studies. So how is it studied? Well, there are some solutions of vector limits, etc. in other media, and this medium is very complicated to study. So how hard was it? I totally approve of the work, and it's worth for the Kasserat continue. No experiments. How do you deal with it numerically? The question is a good one. You should take calculations for a medium without rotation, and as far as I think that this is used very well in composites. Well, you should look at how quickly the wave moves, and then add it to the complications of the medium, and compare it with the classical theory. numerically is verified. You take classically something that has been studied and then compare it to the calculations in the construct continuum. But for example, the solution is found, but is compatible, but not matches. Well, if there are no other factors on the mesh, we decided, Professor Altenbach, your opinion is that the dissertation is a good one, that it deserves the degree to be conferred on this member. I liked this paper. I just had some questions in academic vein. Victor Anatolyevich Yeremeyev, please. Dear colleagues, I would like to use the suggestion for me not to read the whole review because it was published, and so as far as the work, I enjoyed most of all. I would like to focus on what I liked about the work, and then I will ask my questions. And then, of course, I will conclude with the formal part. I like a very detailed analysis of the task of hyperbolic thermoelasticity. And there will be this analysis on the mesh, and this part is the biggest part. Takes the biggest part of the work. It's very interesting. As far as the crack, it's very relevant. This analysis is very much like another approach in the literature, which replaces the interface of the crack with any other area. And the last chapter relates to some special aspects that had been suggested in other works but modified for this medium. And numerical methods are very applicable here, and mechanics of construction, we have a lot of packages, commercial packages of computation, and this is a big area for work in generalized environments. I have a number of questions. I will go over them quickly. The first one is, the main one is this. When you look at linear and non-linear dynamics, you can expect the emergence of the interaction of waves in non-linear states, but not only the changes of such parameters as the velocity of the wave, and it could be worth pointing out which Nabla operator was used in equations of the state, movement, and thermal conductivity, actual or relative. and the and also in some small deformations, equation 9 is an accurate effect of the application of the theorem of divergence, Gauss-Ostrogradski formula, and it's needed to attract to use the equation of mass balance, and also the author uses some unusual designations for material derivatives. For example, in equation 17 and then there are a lot of typos, of course, and stylistic inaccuracies. Well, there are some literal translations from English. Well, of course, the reviewer's task is to criticize the work, but therefore, I would like to state my conclusion is a dissertation of Dmitrii Vasil'evich Matias on the topic of the use of application of spatial description problems, hyperbolic, thermoelasticity, and dynamics of deformable solid body complies with the main requirements of the procedure of awarding academic degrees at St. Petersburg University, and therefore Dmitrii Vasil'evich Matias deserves the third degree to be awarded to him in physical and mathematical sciences. Thank you very much, Viktor Anatolyevich. The next review is from Vladimir Anatolyevich Polansky. Please switch on your microphone, colleague. Yes, thank you. Dear colleagues, I will not read the whole 3 pages of my review, because it states the opposite of this. Without that part, I like the work very much. I see this as a continuation of Zhilin's idea. Later, Pavel Andreevich Milin, when he said, when we write equations from Newton's laws, we understand what states are there, and if which initial assumptions lie behind the formulas. We came up with verified solutions based on general equations, and this is not always encountered in such works. It's a commendable part, and the volume, the mass of the results is huge. I would like to say that the standard structure of this work is not too good for this work, because the literature review is too heavy, because this will never be complete, as my previous colleague said. That you have to. This literature review doesn't cover all the material presented in all the chapters and sections, and there are a lot of ideas on this topic, and maybe there should be a list of sources for each chapter, separate list of sources, more narrowed down. This very interesting work, because Dmitrii Vasil'evich tried to get deep in to show the general approach results in, and in all its assumptions, and in each chapter, each assumption is tested, and the results are produced. And this is a very complete work, and totally complies with the requirements. I already said one comment about the literature review. The second one has to do with the terminology. There's a lot of jargon that has never been that never were described. For example, the height of the peaks of thermal and acoustic fronts differ a lot. And from the context, it's not clear what the author actually means, because what he talks about is the waves and temperature fields, and in the fields of movements, and of course they have obviously different magnitudes, but and of course on page in figure 8 there's a dependence of P, T, P, E, and so on, but there's no deciphering for these what these values mean. On page 38 in formulas 57 and 58, the number of node is not specified, in which the replacement of the derivative scheme of different scheme, and as a result, the formula actually loses any sense. But my conclusion, irrespective of all the drawbacks, is a good work, very consistent from the first assumptions. The final results address the first assumptions and the next assumption, so on. So this is again very consistent, and this is an additional value of the dissertation. I think that Dmitrii Vasil'evich deserves the candidate of sciences degree. Then we continue. Alexei Prokhorovich Kisilov. First of all, I cannot read out loud. Well, nobody asked me to do that for the last 65 years. Therefore, I'll be very short. I'll speak in my own language, say my own words. If I start from the end, I enjoyed the work very much, especially the candidate. Where there's good work, there's always something to find fault with, and the main thing, very interesting and very divergent tasks. Well, they're so divergent that sometimes you lose understanding what's common among them. Well, this is not a drawback really, but it's just a property. In the first chapter, you study hyperbolic thermoelasticity, hyperbolic thermoelasticity is I have no issues with. The second chapter focuses on motivating problems of geophysics, industrial geophysics, and the task of the opening of the crack and the pressure of an internal fluid internal fluid pressure. I would like to talk about multi-component bio environments, media. Well, this is a very relevant topic. There's a lot to investigate here, to say. But the most interesting chapter for me was the last, third one. Very interesting for theoretical study of linear elastic isotropic dispersed medium Coser type without translational degrees of freedom. This is a very classical problem, but approached in a very non-classical way. For the last 200 years, these problems have been solved analytically. I think that I would like to see a close attention to the analysis of other type of border or boundary conditions, if they are any, that derive from the variation principle. But as a result, I would like to say that this is a good work, and the degree should be conferred on the author. I would like to skip the most part. It's very short, though. A lot of words have been said. That this is very good work. I would like to add here that the results of the work found their way to different articles, publications, but that in some of these articles, the author is the sole author without the help of the research advisor, and which testifies to him as an independent established researcher. As far as the comments, the critical comments, the first chapter is mostly controversial for me. I have some questions with linear models of and nonlinear models of a solid and linear model of a solid body and nonlinear model of a gas. I think you shouldn't put a nonlinear model in the first chapter, because we study the linear model of a solid, but is conditioned by not because that nonlinear model cannot be assessed, but it's because you choose not to. The most logical could be a comparison of linear conditions in both media and separately in linear and non-linear models for the gas. On page second, on page maybe yes, you could compare both linear ones and non-linear, linear and non-linear. The second comment is the treatment of the numerical results. You come up with the conclusion that there is an absence of the falling of the acoustic wave, but what happens instead of it, or does the thermal influence prevent the propagation of the hitting waves? Because in the first section, waves are linear, and therefore the differences between them are not qualitative but quantitative, and actually confirmed incidentally in section 1.7 on page 61. As far as these are not necessarily connected. Well, the third one is the linearization of gas equations with the linear equation of the elasticity. When you replace deformation for density. Well, you should have explained more in a better way, because density in differing, which is in difference to deformation, is always positive. So, have you done the linearization in the correct way? Well, you have to be more accurate here, because these two environments, so two media, are continuous, but the deformation can be negative, and as I said, the density is positive. So you have to be very the density can be treated in reference to a constant, a non-zero value. Whatever irrespective of my critical remarks, I totally support this work, and I believe that the candidate deserves the third degree. Now I'd like to side with the colleagues. I enjoyed the dissertation. 3 tasks, very different tasks, have been covered, but I like the single approach that unifies the treatments of the 3 tasks. So I'm not going to mention all the results. and then the stating part will be skipped. I will skip this statement. I really enjoyed reading it, but of course there are some comments, critical comments. The first one was already voiced, and the first was about the setting of the task about the hyperbolic thermal elasticity in a gas. So yeah, I don't think it's self-matching because it's assumed that gas is conductive, thermal conductive, but there are no sideways tension there. The second is in gases with internal degrees of freedom, namely in the air. A great part is in propagation of fluxes is played by relaxation process. The exchanges of forward and internal energies on a molecular level. So next one is the author uses non-finite, dimensionless values when resolving a task, but he doesn't introduce any dimensionless criteria that could have concrete physical meaning. So please address this. On page 29, we have a very interesting new result, a non-linear dependence of the value of the crack opening from the load, and but unfortunately in the text you don't discuss experimental confirmation of such facts. And as far as you should have done what you should have done to give a commentary. First of all, to confirm this effect, there are some the has to do with the mesh, etc. The results are valid, but they're not. There's not enough verification provided. Nevertheless, this work makes a great contribution to the study of thermal elasticity, and of course, I totally support this dissertation and say that Dmitrii Vasil'evich Matias deserves the third degree of a candidate of physical mathematical sciences to be conferred on him. Now, please, this time is for the candidate to answer all our questions. I will start. I already answered Professor Altenbach, and now I'd like to address Viktor Anatolyevich. I agree with the remark that one should expect the appearance of interaction of waves in a non-linear formulation. Probably this interaction is difficult to notice since a small external influence is considered in the work. Well, apparently additional study of this issue is required. Second, Nabla operator. The paper doesn't indicate that all the equations use the Nabla operator in the current configuration. Yes, I should have done it. I agree with the third remark. The fourth, I agree with the remark. In the literature, the material derivative has different designations. In this work, not the most common of them is used. Its choice is due to the borrowing of the distinction from the works of Professor Gerlin. Therefore, I agree with this remark completely. Next, I agree with the remark that the work pays too much attention to dimensionlessness. In fact, dimensionlessness is done in a standard way, and which always are carried out. As far as the works of Zubov, I agree with the remarks. I've studied the works of Zubov. In my master's study, he has some works in spatial descriptions, etc. And it really would have been worthwhile to refer to them. As far as the typos, I agree with the comments. Unfortunately, I should have proofread my work. I just totally agree with this. As far as the next was Vladimir Anatolievich. The next one. As far as the I agree with the remark that the bibliography should have been done for each chapter. I agree with the designations and the some terms have not been referred to correctly. No clear conclusions. I agree with you that the results are very voluminous, but Alexei Prokhorovich, I agree with the remark. In my dissertation presentation, I tried to show the connection between the chapters more clearly, and I agree that it wasn't done so in the work itself. I tried to work on this in my dissertation presentation. As far as the second one, I agree with the remark. Within the framework of a grant from the Ministry of Science of Higher Education, a program was developed for calculating hydraulic fracturing in which three components interact. However, due to the fact that the results of calculations for this program have not been yet been published in journals, a theoretical computational model of a multi-component medium has not been developed, and therefore it's not included in the thesis. I agree with the remark. The third remark, in the future, I will try to consider this the issue of the boundaries and the limits of the boundaries. There's a lot of material to investigate there. Very, very good remark. And Alexei Viktorovich, thank you very much for your remark. It was the shortest, but this was more substantial. There's all the reviews are brilliant, but there's a lot to say addressing these questions. Number one, I agree with the remark. Indeed, it would be more correct to compare the two linear formulations. However, in the part of the work where a solid body and the gas are compared, a small external action is specified, for which the solutions for the gas obtained in the linear and nonlinear formulation are practically indistinguishable. So and therefore I compared them. As far as the second question, I would like to show this slide. This issue was raised at the Indetsev seminar, and there were a lot of questions addressed to me. So I conducted some more calculations that were not included in the dissertation. You see, nonlinear and linear acoustics. The first one that is the initial perturbation, and the second is nonlinear acoustics. You see that the following of the wave is there. If you consider, if we consider thermal conductivity, then the front is more smooth, and this behavior of the wave and doesn't fall abruptly. This is similar to Berger's equation, because when you add viscosity to the system, it prevents the falling of the wave. You see this linearized system for gas in dimensionless form. Well, you see that density can be negative, and at room temperature, non-linearization is carried out. This first was the balance of mass, the balance of the quantity of movement, then the equation of thermal conductivity, and the generalized Fourier law. And I totally agree with the remark. Is this all? Of course, I'm sorry. Yes, your review. Yes, I have confusion here. Sorry. Yes, I found my answers. The first one, I agree with this remark. Of course, I should have studied more complex model of gas. To Well, first we study the effects of thermal conductivity, and then the effects of viscosity and other parameters. And thermal conductivity should be hand in hand with viscosity. I did additional calculations as far as the second remark. After reviewing the review, additional calculations were made taking into account the bulk and shear viscosity, and it was found that with an increase in viscosity, two waves, quasi-acoustic and quasi-thermal, they generate into one thermal wave. The results are presented on this additional slide. As far as the dimensionlessness, I agree with the remark. For a clearer understanding of the physical meaning, it was worth considering another dimensionlessness. The dimensionlessness presented in the work was applied for the convenience of numerical calculations. When using it, the maximum number of coefficients in the equations is equal to 1. As far as the fourth comment, I agree with the remark. After reading the review, I got acquainted with the experimental work. In the literature, a study was found in which the magnitude of the crack opening is determined as a function of time. But in this case, not the pressure, but the constant flow rate of the fluid is set. On the other hand, in numerous experiments where the internal pressure is set, the lengthwise propagation and morphology of the crack are observed. I agree with all parts of the editorial notes number 5. As far as number 6, I agree with the remark. When writing a joint article with Vitokin, as well as a joint article with Ivanova and Stepanov, I participated in the formulation of the problem, wrote my own programs for calculations based on the finite volume method, and also participated in also the results obtained. Are you satisfied with the answers, dear colleagues? Well, the colleagues seem to be satisfied. No questions, no additional questions. Therefore, well, there are no guests at this session. Have you received any questions online? No questions have been emailed. Then I would like to give the floor to the academic advisor. Please. Dmitrii joined the doctoral study program several years ago. We spent a lot of time doing joint research work. I would like to say that all these 6 years, Dmitrii has worked as an engineer 5 days a week, 8 hours a day. All this great work that we see here has been done at the weekend, in the evenings, and this is, I really admire it. And Dmitrii has participated in working on Gazprom orders, and only part of this work was included into the station. This is very admirable, because this the ability of Dmitrii to do a lot of work in a very limited period of time. He combines the ability to look broadly at the question and at the same time deeply into the question, and with close attention to detail. Well, when he writes programs, he is very meticulous. When you look at his programs, you can be assured that everything is good there. But at the same time, the breadth of the issues that he covers is very great, and a lot of issues had to be tackled, and from different points of view, and because there are many issues tackled in this dissertation, and only spatial description is what unites them. And the third thing is what I would like to mention is the ingenuity. Well, yeah, Dmitrii, for example, could have read about it in the literature, but no, he tries to invent something himself. And maybe sometimes he invents something had been invented already before him, or something new. And after this commendable speech, would like to say a few words about the drawbacks. Maybe modesty is, and because I had to persuade Dmitrii to formulate his results that I did it. I came to the conclusions. This and that, and because before that, if you heard his presentation, the previous presentation, you would have never guessed that the fruits of the work were his, actually. And the second thing, it was hard for me to persuade Dmitrii to actually stop and present the work for defense rather than continue working and achieving different other results. Thank you, Irina Alexandrovna. Dear colleagues, since we have online members of the committee, do we have any questions that have to do with the technology and the procedure? No. Dear colleagues, do you have any comments just to say something about the dissertation? No. Take us then. I would like to. We have the time is 3:27, and therefore we can proceed to the voting. We can discuss this work in a closed format by switching off the broadcast. Do we need to do that, or is everything clear? No need. I support this because no unclear things to discuss really in a closed format, and therefore we continue. We come to the stage where we vote. Please answer my question, everyone. I put to the vote the resolution of awarding Dmitrii Vasil'evich Matias an academic degree in physics and mathematical, physical and mathematical sciences, candidate of sciences. I just remind you that the decision of Dissertation Council on awarding the third degree is positive if more than half have voted. Professor Altenbach, I don't disagree. Thank you. Victor Anatolyevich Yeremeyev, I vote for the awarding of the degree. Vladimir Anatolyevich Paletsky, I vote for the awarding of the degree. Alexei Prokstoshkesky, I support Alexei Viktorovich Porobov. I support. As a chairperson, I also support my colleagues and vote for the awarding of the degree, because I think that Dmitrii Vasil'evich is worthy of the degree. Therefore, I would like to announce that out of the 6 members of the Dissertation Committee, six members have voted in favor of awarding the academic degree. Therefore, the decision to award Dmitrii Vasil'evich Matias an academic degree of candidate of physical mathematical sciences and the degree field 01.02.04 mechanics of a deformed solid body has been taken. Do you have any questions as to the procedure? No questions. Therefore, the concluding remarks from the candidate. Thank you very much. I would like to thank the academic committee for the smooth conduct of this, the level of stress has decreased in me, because all the work has been done brilliantly. And thank you for close reading of my work. And because you commented on it, even some of you, even before the dissertation was submitted, and I would like to thank you for your time and your partial attitude to me. Thank you very much. And a separate thank you to the committee chairperson. It was brilliant session with such a committee chairperson. Thank you to my academic advisor, and for the ability to explain things for letting me understand the answer myself, just moving me to it in this direction. Thank you very much. Then I will not take any more of our time. Thank you very much for your good words. I would like to congratulate the candidate on the awarding of the degree. Therefore, thank you very much. The session is now closed. Please switch off the broadcast. Thank you. Thank you.